Hello again, here we are again working out the molar mass of compounds. You'll want your periodic table, so just nip and get that. Press pause. Hello again, here we go. So molar mass of compounds. The molar mass, well, the definition of molar mass is really the mass of 1 mole of a compound, or an element actually. It's got a number of different names. We could also, it's numerically equal also to the molecular mass of a compound, or the relative atomic mass of an element, if it's an element, or it's often just known as the formula mass. Now, a number of you, most of you, won't know what we mean by a mole, other than it being a furry animal that makes holes in the ground and doesn't see very well outside. For the time being, don't worry about what a mole is, we'll get to that later. For our purposes at the moment, we just want to be able to work out the molar mass or the formula mass of the compounds we've got. And for that we need our periodic table, and we're simply going to add up all of the relative atomic masses of all of the elements in the compound, or the formula of the compound. If we look at our periodic table, we'll see that on our periodic table we have two numbers. For instance, if we look at sodium, we'll see that sodium has got two numbers. It's got a smaller number here, the number 11. That's the atomic number. That gives you the number of protons in the nucleus of an atom of sodium. And up here we've got a larger number, here it's 23, and that is the relative atomic mass. Relative mass, the relative atomic mass. And we're going to combine all of those in a compound to find out the molecular mass, or the molar mass. So for instance, for sodium, we've got two sodiums. That gives us 2 times 23. Plus carbonate, well, that gives us plus a 12, plus 3 times the mass of oxygen. Oxygen is 16. And by doing that, we add them all up, we get an answer of 106. Now, molar mass actually has units. They're called grams per mole. Whereas all of the other definitions, molecular mass, relative atomic mass, formula mass, do not have units. Molar mass, we tend to give units of grams per mole. 106. Sodium hydroxide, we've got sodium with 23, and oxygen with 16, and hydrogen with 1. That gives us a mass of 40 grams per mole. Magnesium bromide, magnesium is 24, bromine you'll find is 80, we've got 2 bromines, gives us a mass of 184. Aluminium sulfide, aluminium is 27, and sulfur is 32, which gives us a mass of 150 grams per mole. FeCl2, or iron 2 chloride. Iron, the transition metal Fe, you'll find it in the middle over here. It's got a mass of 56. 56 plus 35.5 gives us a mass of 127 grams per mole. FeCl3, again we've got 3 chlorines now, so we just have to add an extra chlorine to FeCl2, and that gives us 162.5 grams per mole. Magnesium
phosphide. If we work that out, we end up with finding that we get a mass of 134. Gallium nitrate, gallium, you'll find is 70. Now this time we've got some brackets or parentheses, and we'll find that here then. We're going to include our nitrogen. Nitrogen is 14. We've got oxygen. Oxygen is 16, but there's 3 oxygens. 3 16s gives us 48. And that is all multiplied by 2 because of 2 of them. Okay, so if we work out that, we end up with a mass for gallium nitrate of 194 grams per mole. Okay, there you go. And the solutions are all on the blog now. You'll notice there were a couple of mistakes in the solutions to begin with. I've gone and corrected them. If you find any other errors, please let me know. Just one quick thing to mention here. I've realised I've been writing the units as grams per mole. Actually, in chemistry or in science as a whole, the shorthand way of writing mole is grams per mole with just the 3 letters. So actually even better to write it like that. Thanks very much. Good night.